Hi, welcome back. So in this video, we are going to solve October-November 2015 question number 6, which is a circle theorem question. So here, A, B, C, D lie on the circumference of the circle. So find the value of T. So A, B, C, D, all these points lie on the circumference of the circle. We need to find out the angle T here. So we know that the angles from the same segment, they both are equal. That means the starting point is here, A, and ending point is B. The angle formed at the circumference, starting point is A and ending point is B for this. Similarly, for this angle D also, the starting point is at A and the ending point is B. So both the angles that we have here, both the angles, angle D and angle C, both of them are having the same starting and ending point. Angle C, starting point was A and ending point is B. Similarly, angle D also, the starting point is A and ending point is B. In this case, we say that the angles are from the same segment. And in that case, the angle formed will always be equal. Angles from the same segment are always equal. So you just have to check the starting point and ending point. If both of them, if both the angles, angle C and angle D, if both the angles are having the same starting point and ending point, then that means that the angle made will always equal. So in this case, T is 43 degrees. Both of these angles are supposed to be same. So T is 43 degrees. Now moving on to the second part here. X, Y, Z lie on the circumference of the circle with center O. Find the value of W giving reasons for your answer. So now in this case, we can see that OY and OZ, O is the center, so therefore OY and OZ, they both are radius. They both are the radius. That means these two sides are equal. If two sides are equal, then the angles opposite to them, that means this angle and this angle, these two angles are supposed to be equal. That means if this is 28, this will also be 28. Now let's consider this triangle OYZ. 28 and 28 will add up to give me 56. So the angle at the center will be 180 minus 56. So 180 minus 56 will be 124. So the angle formed here will be 124. And the angle W will be, we know that we have studied the circle theorem. Angle formed at the circumference will be half of the angle formed at the center. The angle formed at the center is 124. So 124 divided by 2, which will give me 62. So 62 degrees. 62 degrees will be for W here, because opposite angles of isosceles triangle. Isosceles triangle are equal, or else you can write the other theorem as well. The angle formed at the center, the angle formed at the center is 2 times twice the angle at the circumference. Twice the angle formed at the circumference. Or you can say angle formed at the circumference is half of the angle formed at the center. E, F, G, H lie on the circumference of the circle. Find the value of P, giving a reason for your answer. So here, E, F, G, H, all these 4 points lie on the circle, which makes this quadrilateral a cyclic quadrilateral. Cyclic quadrilateral. We have studied one property of cyclic quadrilateral. Cyclic quadrilateral means if all the points, if all the corner points, or we say that the vertices, if all the vertices of the quadrilateral lies on the circle, then we say that it is a cyclic quadrilateral. And we know that the opposite angles of a cyclic quadrilateral will always add up to give me 180. So 5p plus p, 5p plus p should add up to give us 180 degree. That is the property of cyclic quadrilateral. That is the only property that we study in cyclic quadrilateral. Opposite angles add up to give you 180 degrees. Now 5p plus p is 6p. 6p is equals to 180 degrees. So p will be 180 divided by 6. 180 divided by 6 will be 30 degrees. So P will be equal to 30 degrees. And we know that angles, opposite angles, opposite angles on a cyclic quadrilateral adds up to 180 degrees. Now moving on to the next one here. The diagram shows a circle. The diagram shows a circle with center O. So here we have the center point O. PQ and QR are codes. So PQ and QR, they both are the codes. OM is perpendicular from O to PQ. OM is perpendicular. That means this angle over here is 90 degree. Complete the statement. PM is to PQ. So PM is to PQ. Now, we have studied that from the center, if I am drawing a perpendicular line to a chord, the perpendicular line will bisect the chord. Or we can say that this perpendicular line will divide the chord into two equal parts. So PM we know is equal to MQ. Now the question here is PM is to PQ. PM is to PQ. So this is in the ratio of 1:2. The whole thing, suppose if we take it as 10 centimeter, so this will be 5, this will be 5. So let's just say that PQ, the whole thing, if it is 10 centimeter, this is just an example for you to understand. If the whole thing is 10 centimeter, then PM will be 5 and MQ will also be 5. So what we need here is just writing this 5, 5. What we need here is PM is to PQ. So PM in this case is 5 and PQ means 5 plus 5, that is 10. When we simplify, both of them are coming in 5 times table. 5 times 1 is 5 and 5 times 2 is 10. So that is how we get PM is to PQ as 1:2. You don't have to show all of these working. You just have to directly show the answer only 1:2 because it is a 1-mark question. Now, moving on. ON is perpendicular from O to QR. So ON is also perpendicular. So that makes RN and NQ equal. That makes RN and NQ equal. Complete the statement to show that the triangle OMQ, so we need to draw a line here to make this a triangle. OMQ. OMQ is congruent to triangle ONQ. So dash is a common side. So if we're considering the triangle OMQ and ONQ, I can see that OQ is the common side here. So OQ is a common side. Now, dash is equals to dash because M is the midpoint of PQ and N is the midpoint of RQ. Here, MQ will be equal to NQ because it is given that PQ is equals to QR. So I forgot to mention this point here. PQ, the code PQ is equals to code PQ is equal to RQ. Now, MQ is what? Half of PQ. Half of PQ. And then NQ is what? Half of RQ. So if PQ is equals to RQ, then half of PQ, which is basically MQ, will be equal to half of RQ as well, that is NQ. So from this statement, we can say that PQ, sorry, it was MQ and NQ. MQ is equals to NQ. MQ is equals to NQ because M is the midpoint of PQ and N is the midpoint of RQ. Dash is equals to dash because equal chords are equidistant from the center. So you need to know this circle theorem if you want to solve this question, the last part. We have a circle, the center is over here. Let us say if we have two chords, so this chord, let's say AB, and let me draw another chord here. Let's say this chord is CD. And if these chords are of equal length, let's say this is 6 centimeter, AB is 6 centimeter, and CD is also 6 centimeter, then the distance, let's say this center is O, the distance from the center, the perpendicular distance from the center, the term is important, the perpendicular distance from the center to AB and the perpendicular distance from the center to CD, both will be equal. Let's say that this perpendicular distance, if it is 2 centimeter, this will also be 2 centimeter. So equal chords are equidistant from the center. If the chords are of equal length, then from the center, they are equidistant. So that is the last part which you need to understand here. OM is equals to ON because OM here is equal to ON because equal chords, it's given that PQ and QR are equal chords, are equidistant from the center. That circle theorem, you need to know that. So that's all. Question number 6. It was a circle theorem question. If you have any doubt, let me know through the comment box. Thank you for watching.